Hello, everyone. So this is me, Jorge. This video is to, like I said in the email that I sent earlier today, um, I'm going to basically just go over the unit circle with sine, cosine, and also a bit of tangent. But the purpose of this video is so that to keep you guys from having to memorize, the entire table for all the angles, for all the main angles, right? So what I'm going to do here is more of a geometric interpretation, or like how to use geometry to help you remember the sine, cosine, and tangent values of the main angles. Okay. Now, I expect that this video will be enough for you guys to understand the process and like the trick itself. But of course, feel free to ask me questions tomorrow in class or next time we meet each other in class, in case you still have doubts or there are things that you want me to clarify. Okay, so I'm going to start by sharing my screen. I'm using OneNote, and I've already set up the page, the page on which we will be working. Okay, so share screen, OneNote. Okay, all right. So I've drawn already here 3 circles because, like I said, I'm going to go over the over cosine, sine, and then tangent. Okay, so I've also added here the table of the main angles, just so that the work that I show you can, like, you can check it. Like, we can check it just by going back to this table. But so I want to say a few things before we start working on the circles. So you see that sine and cosine, their values, all the numbers that we see here, from 0 to 1 and then from 1 to 0, it's the same, but it's like the other way, right? It's in reverse. But if we are going to talk about, I guess, the numbers, like how many different numbers we get, well, 0 and 1, we don't really take them into account because they're just like straightforward, right? We know that sine and cosine oscillate between -1 and 1. They don't get out of that range of values, right? So I guess the particular numbers, or the more interesting numbers, are 1/2 and then 1 over the square root of 2 and then the square root of 3 divided by 2. Okay, now I want to say something first. I want to say that in some other tables, and some of you guys maybe remember this value here. Sorry, I'm going to use the highlighter. Remember the value there, the value here for 1 divided by the square root of 2. Remember it more as square root of 2 divided by 2. But they are the same number, right? Because if we take 1 over the square root of 2 and rationalize it, which means we multiply the square root of 2 in the denominator, we multiply it by another square root of 2. But remember that when you do that, you also need to multiply the numerator by the same number, right? Okay, so when we then multiply the two things in the denominator, we get a square root of 2 squared, which then, the square and the square root cancel each other out. So then you are left with, so we have this squared, and then we are left with then 2, right? Square root and the square root and the root and the square power cancel each other out. Now, square root of 2 is just multiplied by 2, by 1 in the numerator, right? So then we have it by itself, we have it by itself. So you see, we get square root of 2 divided by 2, right? So they are the same number. I may use square root of 2 divided by 2, maybe, but I'll try not to. Okay, so there is the demonstration of why square root of 2 divided by 2 is actually the same as 1 over the square root of 2. Okay, now I wanted to realize of something else too, okay, between these values from 0 to 1. So you see that these numbers are increasing in value, right? So 0 goes up to 1/2, and then 1 over the square root of 2 is actually bigger than 1/2. Okay, it's above it. Now, the next one is square root of 3 divided by 2, and that is also above 1 over the square root of 2 above the previous term. And then the last one is 1, right? Now, sometimes, you know, you may remember, how would I say this? Okay, so let's see. Okay, so I mean, I guess what I'm trying to explain here is, okay, so, you know, sometimes you just remember the numbers, right? You just remember 1/2, remember square root of 3 divided by 2, or 1 over square root of 2, and you don't know in which order they are, right? Which one is bigger than what, right? Okay, so, I mean, to begin with, I think the issue is with the numbers that involve square roots, right? Those are kind of like hard to place. Okay, so then what can we do in order to figure out what's bigger than what? Well, here's something that that I think can help. Okay, so first of all, a square root of 2. A square root of 2, of course, has to be between a square root of 4 and a square root. Well, let's just say square root of 3, actually, right? And also between the square root of 1. Square root of 1 has to be less than the square root of 2, and the square root of 2 has to be less than the square root of 3. And of course, the square root of 3 is less than the square root of 4, right? And that is because just because 1 is less than 2, 2 is less than 3, and 3 is less than 4. We are doing the same operation on all of them. And this operation does not change it changes their sizes, right? It changes, like square root of 2 will change the size of 2, but it does it in an ordered manner. Okay, so it keeps the order, like 1 less than 2, 2 less than 3, 3 less than 4. If we take a square root of all of those numbers, the order in which they are does not change. Okay, and so because of this, then we can do we can use this to remember the order in which these 3 numbers are. Okay, and we can do the following. For example, with 1/2 and 1 over the square root of 2. Okay, so we begin with the following. So we know that a square root of 4, for example, we know that that is 2, right? Okay, now if this is 2, if a square root of 4 is 2, then of course 2 is bigger than a square root of 2, right? I hope that makes sense. I think it's pretty clear. Okay, now what happens when you use these numbers to put them below a 1? So like what happens when you do now 1/2 and then 1 over the square root of 2? Well, what happens is that the inequality sign is going to flip, right? Because, for example, let's say 3 is bigger than 2, right? But 1/3, it's a smaller size. It's a smaller fraction of 1 than 1/2, right? Because 1/2 is 0.5 and 1 over 3 is 0.3333, right? So then this is actually bigger. So when you have a number that is bigger than another one, if you then use this to make them denominators of 1, then the order changes, right? So if 2 is, to begin with, bigger than the square root of 2, then when we divide 1 by 2, that is going to actually be less than 1 over the square root of 2, right? So then we can identify then that this one is less than 1/2. No, sorry, 1/2 is less than the square root of 2. Okay, now what else can we do? Now the next thing that we want to do is we want to then know how to make sure that 1 over the square root of 2 is less than the square root of 3 divided by 2. Okay, so for this one, it's going to be, I think, much easier to just remember that 1 over the square root of 2 is the same as the square root of 2 divided by 2. Okay, why is this easier? Well, because if all that we change in here is the number below or under the square root, which is just the number 2 here, right? If all that we do is change that and increase it by 1, turn it into a square root of 3, then of course we are generating a bigger number, right? So then this has to be less than square root of 3 divided by 2, right? So then we know that 1 over square root of 2, which is the same as square root of 2 divided by 2, is less than the square root of 3 divided by 2. Okay, now, now, all of these numbers, all of these weird numbers, 1/2, 1 over square root of 2, and then square root of 3 divided by 2, they all are trapped between 0 and 1. Okay, so I think that's easier to remember, that all these weird numbers, that all these more particular numbers, more particular trig values are trapped between 0 and 1. Okay, so once you have identified the order of those 3 inside, I think it's much easier. Okay, so I just wanted to talk a bit about that in case you just remember the numbers, but you don't remember the order of them, like the increasing order. Okay, all right. So now I'm going to go over sine and then over cosine. Now I want you though, guys, to remember that we don't really know. We don't really need to go over tangent, right? And that is because tangent of x, or well, I guess tangent of some angle, right, is actually the same as sine of that angle divided by cosine of that angle, right? So if we are wondering about tangent of some angle, all that we need to remember is sine and cosine of that angle, and then divide them, right? Divide sine by cosine, and then that will give us the tangent value for that, right? And if you don't believe me, then you could try by yourself, right? You could pick an angle here, 30, let's say, and then wonder, what's tangent of 30? Well, then by this equation, you can find that by computing sine of 30, which is 1/2, and then divide that by cosine of 30, which is this number over here, right? And it should give you back this. Okay, I leave that to you guys as an exercise. Just so that, to make sure that you also are comfortable multiplying and dividing fractions with the square roots in them. Okay, all right, so then let's get started with our geometry trick for sine, cosine, and tangent. Okay, so we're gonna use this first circle for sine. Okay, so I'm going to write here sine of I guess I should have asked this before in class. What letter are you guys more comfortable with when it comes to angles? Because we can use x, right? F of x, and like all the functions that we have dealt with before all involve x. But sometimes with trigonometry, they prefer to use theta, right? This symbol here, theta, to mean angles. More like theta is for angles, specifically just for angles. But I think it's fine if we just go ahead and use x. Okay, so let's do that. Sine of x. Okay, all right. So this is what I propose to you guys. What I propose to do is, for sine, what we want to do is we want to trace, I think most of you guys are familiar with the idea that sine of x is related to the y-axis, right? So what we are going to do is we are going to take the y-axis. Okay, I'm going to highlight it here. Man, this is really bad. Trying to highlight this as fast as I can. Thing is that the highlighter does horizontal highlighting and not vertical. Like if I do a vertical motion with this highlighter, it's just going to draw a very thin yellow line, and that is useless, right? Okay, so I just wanted to highlight the y-axis here. Okay, where is the one that I was using? Okay, let's just change the color of this to dark blue. Okay, sine of x. I don't know why. Oh man, I don't know why my OneNote is deciding to act weird now. Okay, let me change pages, and maybe that would help it. Okay, is that, let's just keep working and see if it gets bad, then I'll probably have to close OneNote and then open it again. But okay, so how does this work? Okay, so the first thing that I did was I highlighted the y-axis. The sine of x is related to the y-axis. And then the other thing that I want to do is, these are unit circles. What does that mean? It means that these circles have radius 1. That's why, hence the word unit. So then what I want to do next is, okay, so I'm using the y-axis here, and I know that this circle has radius 1. So then that means that the length from the center to here is of 1, right? Okay, so I'm going to place that 1 over there, and I want to look at this as the y-axis, right? Now, if 1 is over here, and here's the center, or like the origin, right? Here, you want to see this center as the point where y has value 0, okay? So if y has value 0 over here, and over here 1, then down here, it will have value -1, right? Okay, so that's how I want you guys to begin with, okay? All right, so then what is the next thing that we want to do? Like I said before in class, we are going to only worry about the main angles between 0 and 90 degrees, including 0 and 90 degrees. Okay, so then, 0 degrees is here, right? And 90 degrees is here. Okay, now, how do you get their sine values? So sine of 0, how do we find sine of 0? Well, all that we need to do is we need to know where this point over here, that corresponds to degree 0, where its shadow on the y-axis lands. Okay, so this point over here, degree 0, has its shadow directly onto the origin, right? And remember that at the origin, the y-axis has value 0, right? Takes the value of 0, right? So this is over here, 0 degrees, or just 0 radians, right? You could also see it like that. I'm going to use radians, okay? Not going to bother with degrees. Maybe for the table we'll go back and using 0 for degrees. Okay, so this is the angle 0, and its sine is going to be 0 because its shadow on the y-axis is 0, right? Okay, now what about the other one over here? So this over here is the angle pi divided by 2, right? Because remember that pi radians is 180 degrees, right? So 90 is just 1/2 of it, which is pi over 2. So pi over 2, it's up here. Okay, now what is its sine value? What is sine of pi over 2? Well, the point here, its shadow is directly on the y value 1, right? So then that is its sine value. So sine of pi over 2 is just directly 1 because that's the shadow on the y-axis. Now let's write down here also what we got for sine of 0. The shadow of this point is just 0 on the y-axis. So then its sine value is 0. Okay, now what about the other ones? Well, here I want to do something. Okay, so let's see. So, the other ones are 30, 45, and 60 degrees, right? So you want to see 30 and 60 as the two angles that split the stretch from 0 to 90 into 3 parts, right? 0, 30, 60, and then 90, right? 3 equal parts. So let's draw them. Let's draw them. Let's see. 30 degrees, let's say, is like here. I'm trying to guesstimate the angles. Another one will be maybe over here. Okay. All right. Let me erase this pi over 2 and write it more as sorry, I don't know why this is up here. Sine of x. Let me write it over here like this. Pi divided by 2 corresponds to this point over here. Okay, so now what is it that we are doing here? This is 30 degrees, right? 30 degrees is 1/6 of 180. 180 is pi. So then 30 degrees must be pi over 6, right? So this is pi over 6. And this other point over here is 60 degrees, right? 60 degrees is 1/3 of 180. 180 was pi, 1 pi, right? So then in radians, 60 degrees is pi divided by 3. Okay, so just as a reminder, I'm going to write here. Pi radians is equal to 180 degrees. Okay, so this, for those of you who maybe don't remember it quite well. Okay, all right, so then, you know, in order to find their sine values, I must find where these points, these angle points, where their shadows are on the y-axis. Okay, so you see that the shadow of this one is over here, right? And here I'm going to ask you to believe me that this is roughly halfway through, you know, the path from 0 to 1, right? 1/2. So then sine of pi over 6 is 1/2. Okay, and in fact, we can go back to the table and you see that sine of 30 or pi over 6 is 1/2, right? And right here, pi over 4 and then pi over 3. Okay. Now, what about the other one, pi over 3? Well, let's also just go ahead and place pi over 4. Pi over 4 is 45 degrees, right? I mean, okay, in degrees it makes sense. 30, 45, well, 30, 60, and then put 45 right in between 30 and 60, right? Because it's exactly halfway through, right? The distance between 30 and 60 is that of 30. And then if we split that in 2, that's 15. So 30 plus 15, 45, right? So the angle is here, halfway through. That's 45 degrees. But now if you put it in radians, well, 45 times 4 gives you 180, right? Because 45 times 2 is 90, and then 90 times 2 is 180. So then 45 is 1/4 of pi, right? So pi over 4. Sorry, why did I write 6? Pi over 4. Okay. You know, all that we need to do next is we just need to find the shadows of these 2 points on the y-axis. Well, they are roughly here, and then the other one roughly here, right? Now, we remember from before that the next 2 numbers that come after 1/2 are 1 over the square root of 2 is the next one, and then the next one was the square root of 3 divided by 2, right? And so then it makes sense because, you know, these numbers over here, 0, then 1/2, we are going up in order up to 1, right? So then for this point over here, the next one after 1/2 is 1 over the square root of 2, or the same as square root of 2 divided by 2, right? And I explain why that is the case. Now with pi over 3, since the shadow is much farther away from 0, so it's a number that is bigger than 1 over the square root of 2, the number that goes there is going to be square root of 3 divided by 2, right? Because we need to remember those 3 numbers: 1/2, 1 over the square root of 2, and then square root of 3 divided by 2, and that they are in that order. Okay, so those are the angles there, the main ones. Okay, so I wanted to also just you know, I guess connect them to the origin like this. Okay, now what is the next thing that I want to do? Well, I want to show you now, guys. Oh, sorry, let me write the result that we just got. Okay, so we had written sine of pi over 2, sine of 0, sine of pi over 6. The next one was sine of pi over 4, which was 1 over the square root of 2. And then we had sine of pi over 3, which is square root of 3 divided by 2. Okay, I don't know why this keeps disappearing. sine of x. Okay, this is annoying me. I'm going to just erase this part. Oh no, I didn't want to erase that. Okay, I think I'm just going to select it and delete. There you go. Okay, so I'm going to just write here with this thick marker, sine of x, like that. Yeah. Okay, now, why do I say that these angles are enough to find, to remember the other sine values? Well, I say that because, so let's say you are told to find sine of, let's see, 120, right? So 120 is 90 plus 30, right? And so it would be, the same as what we did over here of splitting this stretch into 3 parts. If we split that, like here and then here, we will then get, this is 90 degrees, then this is 120, and then this is 150, and this is 180, right? Now, if we want to write that in terms of radians, let's see. So 30 degrees is 1/6, right? Over here, with 90 degrees is pi halves, right? Or in terms of 30s, there will be 3 30s, right? 90 is 3 30s. Now, 30 is pi over 6. So the 90 degrees is 3 pi over 6, right? So this is 3 pi over 6, right? So then the next one will be 4 pi over 6. And then this one will be 5 pi over 6, right? Pi over 6 is 30. And then here there will be 6 pi over 6, which makes sense because then we can cancel out the 6, and then we're left with pi. And pi is 180 degrees, right? Over here, you will be left then with 5 pi divided by 6. That cannot be simplified, right? Let's erase also this 6 pi over 6 and write just, oh no, let's just write pi. Okay, and then for 4 pi over 6, we can simplify that and make it, this 4 we can divide it by 2 and we get 2, and then this 6 divided by 2 and we get 3, right? So 2 pi thirds, 2 pi over 3, 2 pi divided by 3. Okay, now how do we find their sine values? We are going to do the very same thing that we did before. We are just going to look at those points and look at their shadows on the y-axis. So the shadow of this is going to be exactly the same as the shadow for pi thirds, right? So then, let me erase this part. Yeah, this was square root of 3 divided by 2, right? So then that is its sine value. Sine of 2 pi over 3 is just, it has the same shadow as this other one, and we knew that for pi over 3 it was square root of 3 divided by 2, right? Now the same happens with 5 pi over 6. Its shadow is the same as the shadow of pi over 6, which gave us 1/2, right? And then similarly, if we go ahead and try to place, the point here that is in between, then the shadow of that one will be the same as the one that we got for 45 degrees. Okay, so what is this angle here? Let's see, this was 2 pi thirds, it was 120, right? 120 degrees, and this other one was 150 degrees. So there's the total distance between them of 30 degrees. If we split that in half, we get 15, right? So the midpoint is 15 away from 120. So we just need to add 15 to 120, and that is 135 degrees, right? So this is 135 degrees. Okay, and so then we know that sine of 135 degrees is the same as what we got for sine of 45 or sine of pi over 4, which is just 1 over square root of 2 or square root of 2 divided by 2, right? Okay, so we got all these ones over here. Now, how do we do to get the ones over here on the bottom half of the circle? That's not going to be too different. It's just going to be the same as what we did before, except that now all the signs will be reversed. Okay, so let me connect this to the origin. Then let me connect this also to the origin. And then we have this exactly between, right? Okay, now what about the ones below, the ones here? Okay, so let's keep making this splits of 30. Okay, and then, you know, the 45 in between. Okay, so then let's see. This stretch over here usually should split into here, and then here, and then over here should be this, and then this, and then here exactly in between. Okay, so what are their sign values? Well, again, you just need to identify, you know, where their shadows are on the y-axis. So this point over here, this point over here, and this point over here. So this one has a shadow, again, exactly halfway through the space between 0 and -1. So then this is -1/2. Okay, now this other point over here, this other angle, has its shadow here, and then this last one has it here, right? And remember that the order is 1/2 and then 1 over the square root of 2. So then over here we have 1 over the square root of 2, but it has negative sign. Okay, and then the next one is square root of 3 divided by 2, right? So square root of 3 divided by 2, but with negative sign, right? Okay, now what is this angle? This angle over here is -30 degrees, or you can also see it as, let's see, so we said that pi over 6 is 30 degrees, right? Now, an entire circle is 2 pi's, right? So we did here, half a circle, 180 degrees is 6 pi over 6, right? So 6 of them, 6 times 30 degrees. And then we do how many more? We do 1, 2, 3, 4, 5. So we had 6 and then 5 of them, that is 11. So 11 pi divided by 6, right? Which is the same as, so everything is 360, but if we do 30 before that, that is 330 degrees, right? So it's 330 degrees. And we know then that sine of 11 pi over 6 is -1/2, or sine of 330 degrees is -1/2, right? So that is all that you need to remember. You just need to remember the points that are between 0 and 1 on the y-axis, the order in which they are, right? Just 1/2, then 1 over square root of 2, and then square root of 3 divided by 2, right? And then we just need to identify the angles and see where their shadows match or like fall on those 3 spots. Just that. That's all that we need to do. Okay, and just remember that, you know, over here is +1, and then over here is up down to -1, right? And yeah, so similarly, let's say this angle over here. This angle over here is, you know, this was 6 pi over 6, and on this one we do just one more, so that's 7 pi over 6, right? And that is how much in degrees? Well, this half was 180, and then plus 30, that's 210, right? So 210 degrees for that. And what is the sign? Well, it should also be the one that corresponds to 1/2, -1/2, right? So then sine of 7 pi over 6, which is the same as 210 degrees, is -1/2. Okay. All right. So this is more or less how I like to, I guess, you know, build the unit circle. Okay. If you are thrown if you are thrown a random angle, a random main angle, you know, like one of them is given to you for a question, then what you want to do is you want to, first of all, place it on the circle, place it on the unit circle, and then see, you know, which, so like that random angle is going to be related to one of the main angles between 0 and 90. Okay, you just need to relate it and figure out which one that is. Because once you know what it is, then it's going to be either the sine of that main angle between 0 and 90 or the negative version. Okay, so that I guess covers the entire unit circle, right? Okay, now what about cosine? Oh, let's now deal with that one. Cosine of x. With cosine of x, because we know that cosine is related to the x-axis instead of the y-axis like sine, then we are going to do the very same thing, except that now we are using the x-axis. Okay, so what we want to do is, let me highlight. Yeah, just highlight the x-axis. So you see how it's much easier than before, just highlighting. And what we want to do is we want to place 1 and -1 on there, as if it was, you know, just a number line, right? So we want to place 1 here. This is the origin, right? 0, and then this is -1. Okay, and we are going to do the same. We are going to place the angles, the main angles, and see where they land. Okay, so let's see. 1/3, 30 degrees of this stretch will be maybe here. And then the other one will be here. Yeah, will be here. And then we have the one in between, right? 45 degrees. Okay, so let's write them in radians. Let's use blue. So that is, you know, pi over 6. This is pi over 4. And this is pi over 3. And because this time we are dealing with the x-axis, we are just playing with the x-axis, then we need to find their shadows on the x-axis. So if we do that, you know, pi over 6 has its shadow here. Pi over 3 has its shadow around here. And then pi over 4 has its shadow around here, right? Now, which one of those three seems to be the one that lands on exactly halfway through? This one here, right? It's super clear that it's there. So then here is where we place 1/2. And then over here is where we place 1 over the square root of 2. Sorry, I didn't write square root of 2, square root of 2. And here is where we place square root of 3 divided by 2. Okay, so then we have already the cosine values of these angles, right? So we have that, you know, degree 0 is here, right? But 0 is on the x-axis at 1. So then cosine of 0 is 1. Then what's the next one? The next one is pi over 6. Cosine of pi over 6 is its shadow on the x-axis lands on square root of 3 divided by 2. And we can go down to the table and check. Cosine of pi over 6, which is 30 degrees, is here. Square root of 3 divided by 2. See, it's the same. Now, what about cosine of pi over 4? Well, its shadow lands on 1 over the square root of 2. And then cosine of pi over 3. That's the one that lands on exactly halfway through, which is 1/2. Right? And that is it pretty much, because for the rest of the angles, we just need to, you know, again, just identify where they land on the x-axis, right? So let's see. So of course, you know, let me do this in a faster way. So you see this 1/2 over here also corresponds to this angle here. This 1 over square root of 2 corresponds to this angle here. And this other one corresponds to this angle here. right? And you see that these are also the angles that split the stretch into, you know, these 3 parts first into thirds, right? And then we have the one that is right in between, right? So then what are these? What are these angles? Well, let's see. This is 2 pi, right? 0 degrees is the same as 360 degrees, and 360 degrees is twice 180. And let's remember that 180 is pi, right? So 360 is 2 pi. So in terms of pi over 6, 2 pi is the same as 12 pi over 6, right? So if we take away 1/6 from it, we are at 11 pi over 6, which is what we had got over here also, right? And then if we take out another one, that is 10 pi over 6. And this is the angle in between, right? And so, you know, because we know where these have their shadows on the x-axis, we know then that, for example, cosine of 10 pi over 6 is the same as 1/2, right? And then similarly, let's see. If we do 120 and 150, you know, those should correspond to also the other values. For example, here pi over 3 has had its shadow here, right? Let me find this one. Okay, so this part, if we put it into 3 parts, it will be here and maybe then like around here. Yeah. That, and then halfway through. And their shadows are let's see. This one is the one that is closer to 1, right? This one is the one in between. So 1 over square root of 2. And then this one is the one that lands halfway through exactly, right? But let's remember that this side is the negative side of the x-axis. So this is negative 1/2. This is negative 1 over square root of 2. And then this is negative square root of 3 divided by 2. Okay, and these are also then the angles, I mean the cosine values that correspond to these other angles here. One here, and then the one here. Okay, and that's how you get them. That's how you get the cosine value of the other, you know, the angles on the entire circle, right? Just by using the ones, by remembering the ones from the very, like from the first quadrant. Now I'm forgetting about this one over here, pi over 2. Well, its shadow lands on exactly on the x-axis. It lands on the value of 0, right? So then cosine of pi halves is equal to 0. Okay. All right. So we're almost done. We took care of sine and of cosine. Now the next one is tangent. Again, you can just use the formula here to get the tan value of an angle, right? But the thing is that we can also use geometry to more or less predict what is going to be the value. Okay, so first of all, let's remember that our radius, so we're doing here tangent of x. So I'm gonna write it here, tangent of x. And to begin with, radius 1, right? This circle has radius 1. So this is the length of here is 1. Then over here also length of 1. Okay, but I'm going to pay attention to, so in the, before with sine, we work with the y-axis. With cosine, we work with the x-axis. Now for tangent, we want to work with this imaginary tangential line. Okay, so this line, this blue line that I've drawn right next to the circle is the axis that I'm going to be playing with. Okay, now I called it tangential because it touches the circle on exactly only one point. Okay, so when you have a curve and then there's this other line that touches the curve on exactly one point, that line is said to be tangent or tangential to that curve. Okay, so in this case over here, this line over here is tangential. Tangent or tangential to the circle. Okay. Now, this, I said, well, the reason why I wanted to remind you guys that we are dealing with a radius of a circle of radius 1 is that I want to also see that length reflected on this tangent line. Okay, so you also want to see it as a number line. Okay, so here's the value then of 1, and over here, so let's see, -1. So I also then want to place here -1. Okay, because that is the length, right? The length here is the same as the length here, and we know that the radius has the circle has radius 1, right? Okay. Now, how are we going to then place the angles on here? Well, we also need to remember the 3 weird numbers that come out of tangent. Okay, so those are with tangent, we don't have an upper bound. Okay, because so before with sine and cosine, those numbers only went between -1 and 1, right? It doesn't get beyond those 2 numbers. It doesn't get out of that interval of values. With tangent, you can go from -infinity to +infinity. Okay, so it's different in that way. But the numbers that we usually remember for the main angles, for like 0, 30, 45, 60, and 90, are the ones that I list here. Okay, and so how do we get these numbers? Well, first of all, just remember that, okay, so 0 is going to come out of it, 1 is going to come out of it, but there are 2 weird ones that are 1 over the square root of 3, which, if you rationalize, you get a square root of 3 divided by 3. So these are the same number. And we have a square root of 3. Okay, now, I think it's easy to see, why 1 is bigger than 1 over square root of 3, and then why square root of 3 is bigger than 1. Well, first of all, the square root of 3 is bigger than 1 because the square root of 3 is bigger than the square root of 1, right? And the square root of 1 is just 1. So 1 is less than the square root of 3, right? Now, what about comparing the other two? What about comparing 1 and 1 over the square root of 3? Well, we wrote before that 1 over the square root of 3 is bigger than 1, right? So what happens then if we use these numbers to make them denominators of 1? Well, then the order is going to switch, right? If we decide to place this 1 as the denominator of 1, so the reciprocal, we get 1 over 1, right? And with the other one, we get 1 over the square root of 3. And the sign, the equality sign changes. And 1 over 1 is just 1, right? So 1 is bigger than 1 over the square root of 3. Okay, so that's how you can remember the order. Now, okay, again, remember square root of 3, 1, and 1 over the square root of 3. Okay, so those are the values. Okay, now, how do we then use the angles and attach them to those numbers? Well, if you place 30 degrees, that is 1/3, so that would be here, and then 60 will be here, and then 45 will be here, right? Now, if you trace these and connect them to the origin like we did before, so let's say like this, and then like this, and then the one that is halfway through 45 degrees. Okay, so we have drawn those angles. What we need to do is the lines, we need to keep drawing them. We just keep going. Okay, so this line, for example, the dashed line, if we let it go, it lands exactly on 1. Okay, and that is why tangent of 45 is 1. Because it lands on the tangent axis, on the tangential axis, on this tangent line, it lands exactly on the value of 1. Okay, now, so that is for 45 degrees. Now, what about 30 degrees? Well, if we let it continue, it lands here. And we know that, of the weird numbers, the one that is below 1 is square root, 1 divided by square root of 3, right? So then that's the one that goes here. And for the other one, for 60 degrees, we let that line, if we let it continue, it's going to land beyond 1, like after 1. And of the weird numbers, we know that the one that is beyond 1 is square root of 3. Okay, so that's how you get it. Now, for the other angles, all that you need to do is you just need to let these lines keep going, but in the other direction. So like, for example, okay, yeah, for 30 degrees, it was 1 over pi over 3, right? But this tangent value is also the one that corresponds to the angle here. With 60 is the one that corresponds to this angle here. And with 45 is the one that corresponds to this angle here. Right? So now you see that this is 180, right? Then plus 30, that is 210. And then plus 30 was 240. And then over here is 270. And halfway in between, that is, distance of 30, halfway through 15. So 210 plus 15, that is 225 degrees, right? And so tangent of 210 is the one that is the same as tangent of 30, and that is 1 over the square root of 3. Tangent of 240 is the same as 60 degrees, and that is square root of 3. So tangent of 240 is 60 degrees. I mean, tangent of 240 is square root of 3. Now, what about the negative? Well, what about then, this other side, the negative side of this tangent axis? Well, the one that goes halfway through, which is, negative 45 degrees, will have tangent -1, right? Because that's where it lands. But what if this in radians? Well, let's see. So 45 degrees is pi fourths, right? So pi fourths would have 1, 2. No. Okay, 45 degrees is the same as pi 4 radians, right? Now, how many do we have up to here? Well, we have 1, 2, 3, 4, 5, 6, 7. 7 of them. Okay, so then this angle over here is 7 pi fourths. Okay, and yeah, so its tangent is -1. Now with the other ones, it's pretty much the same. For let's see, this is like the 30 and then another 30. So then if we let it go, it lands there, but then this is the one that is below -1, which should be -1 over the square root of 3. And then the other one that lands here, we let it continue. That's the one that is after -1, and that is negative square root of 3. Okay, so that is how you use shadows for sine and cosine, and then for tangent, you just let it land on the tangent line. To see what the values are, to see what the sine value is, to see what the cosine value is, and to see what the tangent value is. Okay, but like I said, if you want to just reduce the amount of things that you need to remember, I would say that you don't worry about these geometric understanding of tangent, but just worry about sine and cosine. Okay, because tangent, you can obtain it by dividing sine by cosine, right? But yeah, this is all that I wanted to explain, and this is what I was going to talk about in class, but we ran out of time. And I also don't want to use that time to more like next time, because we can use it, just doing more presentations, or maybe having some work time in class, or maybe just doing some more lecture. Okay. All right. So I hope that this video was helpful to every one of you. So please, like I said before, feel free to ask me questions next time in class. Okay. So see you guys.